Reading 12.2. What happens to mass during a chemical reaction in a closed system? Getting ready. Did you know when you play with glow sticks you are watching a chemical reaction in a closed system? In class, you learned about what it means for a chemical reaction to take place in a closed system. The sandwich bag experiment was an example. When you combined the reactants in the bag, you observed a chemical reaction inside a sealed bag. Scientists called this a closed system. Nothing was added to the chemical reaction while it was taking place, and nothing was allowed to escape. This reading helps you to think about why open and closed systems are important. Read to find out more about how glow sticks work. As you read, pay attention to the difference between measuring mass in an open system and measuring mass in a closed system. An everyday reaction in a closed system. Glow sticks. Have you ever played with glow sticks, necklaces, or other items that you can buy at parades, concerts, fairs, and festivals? All of these glow items are examples of chemical reactions in a closed system. When you buy these items, they may already be glowing. In that case, someone has started the chemical reaction. They do this so you will see the colors and want to buy something. If you buy a glow item that is not already glowing, you need to start the reaction yourself. Some emergency lights that people keep in their cars need someone to start the reaction. Some hand warmers work the same way. Here is what happens. Inside of these items is a tiny thin glass tube. The tube contains substances that will glow when they are mixed in with the materials in the outer container. To start the reaction, a glow stick has to be bent. When you bend a glow stick, you break the tube and the substances inside of it to spill into the glow stick. When those substances mix with other substances already in the glow stick, a chemical reaction takes place. This particular chemical reaction produces new substances and also a glowing light. Glow sticks cannot be used again. This should make sense to you now. Once the tube is broken and the substances have interacted, there is no way for the reaction to start over again. The chemical reaction has made new substances. All of the original atoms from the starting substances are still there, but the atoms have rearranged to form new substances. The reaction inside the glow sticks is similar to the reaction that causes fireflies to glow. You may want to look in science books or on the internet if you would like to learn more about how that happens. Conservation of mass. Thinking about the plastic bag experiment and a glow stick. In the plastic bag experiment, if you had placed the bag on a balance before and after you had mixed the reactants, you would have observed that the mass stayed the same. The mass would have stayed the same before and after the chemical reaction because the bag would have contained all of the same atoms. If you placed a glow stick on a balance before you broke the tube and after you broke it, you would have seen that the mass stayed the same. A chemical reaction does not create any atoms or destroy any atoms. Instead, a chemical reaction rearranges atoms to make new substances. This is why the mass stays the same. This scientific principle is the conservation of mass. Conservation of mass is the principle that regardless of how substances interact with each other, the total mass of the system always remains the same. What if you had opened the plastic bag? In the plastic bag investigation, if you would have opened the plastic bag, the glass would have been allowed to escape. Once you opened the bag, it became an open system. The mass of the plastic bag filled with products from the reaction would have changed because gas would escape from the bag and gases from the air could go into the bag. You do not have to add the air yourself. The molecules in the air will move into the bag by themselves, and the molecules of gas in the bag will escape without your help. Looking closely at mass in a closed system. Look at the following table. Imagine that Tiffany determined the mass of the reactants before a chemical reaction. Then she determined the mass of the products after the chemical reaction in a closed system. Her results are in the table below. According to the principle of the conservation of mass, the mass of the sodium sulfate was the following: A, 71 grams, B, 89 grams, C, 31 grams, or D, 107 grams. Circle your answer. How do you know that your answer is correct? Write a scientific explanation about how you know the mass of the sodium sulfate has to be in this reaction. Thinking about the types of atoms in a chemical reaction. In everyday language, people say that an object rusts. Now you know that the scientific name for rust is iron oxide. Iron oxide is produced when iron and oxygen come together in the presence of water and interact. The chemical reaction called rusting can only happen when there are iron atoms as one of the reactants. Use what you know about the atoms involved in a chemical reaction to answer the following two questions. You may have wiry cleaning pads at home for cleaning the grill or for pots and pans in the kitchens. These cleaning pads often contain soap, but the metal in them is called steel wool. Steel wool rusts if you use it, then leave it on the edge of the sink. What must steel wool be made of in order for it to rust? If you have seen steel wool cleaning pads at home, you can actually see evidence of this reaction. Why do you think rust cannot form on other substances like plastic or rubber or even other metals like aluminum? Think about the number of atoms in a chemical reaction. You now know that not only do the type of atoms in a chemical reaction stay the same, but the number of atoms also stays the same because the mass is always conserved. You can look at the number of atoms involved in the process of rusting as an example of this. The chemical reaction that causes rusting can be written as the following chemical reaction. Another way to write the equation is to use the chemical formulas. Using the chemical formulas, you can count the atoms on each side of the arrow to be sure that the number of atoms is the same. When the number and type of atoms are the same on both sides, scientists call the equation balanced. The number in front of the element or compound tells you how many atoms or molecules you have. In the equation below, the 4 in front of Fe means there are 4 atoms of iron. The subscript in the oxygen, O2, means there are 2 oxygen atoms in every molecule of oxygen. Altogether, there are 4 iron atoms, Fe, and 6 oxygen atoms, O, on each side of the arrow. The atoms are arranged differently, but they are all still there. The equation balances because of the principle of conservation of mass. In a chemical reaction, the atoms rearrange, but the number of atoms always stays the same. Why does mass stay the same in a chemical reaction? Mass stays the same in a chemical reaction because the same atoms that are in the reactants rearrange to form the products. All the atoms are still there, so the mass stays the same before and after the reaction. Applying what you have learned about the chemical reaction and the conservation of mass. In class, your teacher burned magnesium so that you could see a chemical reaction similar to the one that occurs in sparklers and fireworks. When the magnesium was lit, the oxygen in the air interacted with the magnesium to form a new substance. magnesium oxide. In this unit, you have talked about several metals: magnesium, gold, copper, and aluminum. Sodium is another metal. In this investigation represented below, a student places a piece of sodium, Na, in water, H2O. Remember that the model shows only a few atoms, even though millions of atoms are actually in the sample of the substances. Think about the principle of conservation of mass as you look at the diagrams. A student places a piece of sodium in water. When sodium reacts with water, 2 atoms of sodium react with each water molecule. Here is a model to represent the reactants. Here are some possible ways to represent one molecule of each substance after they were put together. Some of these are possible and some are not. Use the diagram above, choices A, B, C, and D, to answer the following questions. Which of the choices, A, B, C, or D, could represent the products of a chemical reaction in a closed system? Give reasons for your answer. Choose any one of the other choices, A, B, C, or D, that you did not choose the answer to question 1, and describe what you think that example shows.